up and try again.
So welcome. In this session, I'm going to discuss how to interact with Java. This is a very first session that you can basically do with Java. Today, we're going to talk only about interactions with Java, and I'm going to demonstrate the different data types. Java contains 8 different primitive data types that will allow us to basically store information in different formats. When we talk about data types, we're referring about how is the machine recognize different numbers, letters, characters, special characters, bytes. So those are the special characters that we actually provide to the machine and then stores into memory. They're called data types. Of course, there is a different concepts about data types and in referring in computer science and software engineering, but here we're talking about the most primitive data types in Java. So I'm gonna give you a demonstration in Dr. Java, but first let's take a look at this presentation that I create for you. So welcome to the very first class that you're probably gonna take in Java. We're gonna talk about variables, data types, and the operations that you can perform in Java. So this is a demonstration for primitive data types and this string. In Java, we discuss that in order to store information, we need a placeholder. A placeholder basically is the fancy name for a variable. So a variable is a placeholder which is value eventually change. Probably we already have that notion. And you probably remember that from your math classes, like what is X, Y, Z. All those variables are name of the variables to store numeric values. But in reality, a variable is a placeholder where in this value eventually change. The opposite of a variable is a constant. A constant won't change. That value will stay there forever. That's why we have the value, for example, of pi, which is 3.1415, and so on, Euler's constant, and whatnot. So a variable is the opposite. That value will change. Of course, there's different types of variables, and the way we store that information in the memory of the machine, we need to recognize what kind of type we're holding it. For example, here, I'm just going to tell you, Java counts with 8 different primitive types. So you can see them here listed. And I'm going to talk about string in a little bit about an object way. But let's start with the very first one. An integer, long and short, they're corresponding to numbers. That is a numeric way you're going to store a whole number. Remember that in numbers, we have real numbers and we have whole numbers. So here, we're going to store whole numbers. So integer, long, and short, as the number says, it depends for any types of whole numbers. Now, for real numbers, we have double and float. This corresponds primarily for only any real number. Anything that you deal with decimals, anything that you have with precision, you have to deal with floats and doubles. And then we come with chars. Chars are characters. Basically, any character that you can represent with a keyword that you have there, that is a character. You have lowercase, uppercases, numbers, special characters, whatnot. Those are characters, and those are denoted with one single character. For example, here I have the number 5 with one single quote around the 5. That's considered to be a character. Also the letter A, also the letter N capital, the @ sign. Notice that that single quote represents the single character. That is the way we're going to provide the value to that character. And then we have the booleans. The booleans basically is a way to relate if something is true or false. We're going to deal with what we call sentinels or boolean values or true values. So that is the way we're going to represent that condition by having a boolean statement. So true and false, notice that they're in a different font is because true and false is what we consider to be a keyword. So that is the value that we're going to have for a boolean. And then we have byte. So byte is anything that you can represent the computer with zeros and ones, right? We're gonna talk about bytes maybe later on, but a byte is basically that representation of zeros and ones. Now, those are the 8 primitive types. And then we're gonna have we're going to talk about string later on. The string is not a primitive type. A string is an object. And I know that you're referring to what is an object. I mean, I'm going to keep talking about objects a lot because this course has infused what we call object orientation programming. Java is an object oriented programming language, which means that we can take the power of a lot of different attributes that offers object oriented. So here is something that we're going to discuss later on, but string is the very first object that we're going to deal with. So today we're going to talk about a couple of methods with that. I want to show you this table because in everything in the machine, yeah, has an assignated decimal value. If you can see these characters that you can see here. So first of all, this table, I'm not so sure if you're familiar with it, it has a decimal, hexadecimal, and a character. The characters is that what we're going to discuss today, and how that character contains a decimal value. And I'm going to give you that demonstration in a little bit. And I just like this table because that will show you the correspondence of each of those characters. We can come back to this table in a little bit. So let's write some interactions using Java interactions. This will demonstrate the different data types. Let's do it. So here we have a Dr. Java, yeah, and some of you are using a different ID to basically demonstrate this. Please do so. Right here, what I'm doing in Dr. Java is because I like the interaction so much. It's very quick, it's clear, and they will show you what really want. I just want to give a gentle introduction to Dr. Java, for example. In Java in general, you can do things, what is 2 plus 2, for example. And Java will tell you 4, and then you can do what is 5 minus 2, and Java will tell you 3. What is 5 times 2, and Java will tell you 10. And you can do 5 divided by 2. And here is when your concerns really start in computer science. You might think it's 2.5, but in reality it's only 2. I know this breaks your heart, but at the same time you will recognize it why. And the reason is because a whole number, which is 5, divided by a 2 whole number, what do you think Java is going to recognize at this point? Whole number divided by a whole number is going to give you a whole number, which is 2. And in reality, technically speaking, that is not true. We were expecting 2.5. But because of this fact, we need to recognize that Java is this kind of picky, especially because we need to understand that Java holds what we consider to be primitive types. We need to recognize the real numbers, in this case, doubles. So what we can do is 5.0, for example, divided by 2.0. That is a different story. Here's when you get precision, and precision 1, then precision you get. You see how that's the difference? Now, if I do 5.0 divided by 2, only a whole number, what do you think is going to happen? So here might think, well, there's two different situations, Professor. One is with the whole numbers, the other one is with the real numbers. So what is going to happen? Java has something called precedence. Java will basically consider what is the maximum capacity that you have here. For example, a double stands for double precision, has more capacity than a whole number. So Java will say, well, if we already have a double precision, we might as well stay with the double precision in this case, 2.5. We can do similar situations. If I decide to do whole number divided by a real number, which is double, also it will be that situation. So that is what the data types basically start to taking place in computer programming. We have a whole number, which are very important for many different applications, but we also have what we consider to be real numbers, doubles, right? That gives it the precision. So here we're gonna start working with a couple of them. The next thing is that suppose that we have, let's demonstrate the storage of a variable. For example, now that we're dealing with numbers, for example, we can say that x is a favorite variable for everybody who's been taking math for a while, that's what your teacher told you in high school, or I don't know when, that a variable basically is an x, but it's not really an x. It's basically something that holds the number as we mentioned. So here we're going to have a value, for example, 5. X gets 5. Now, this is not the equal signs. I know many people have told you that the equal signs, that means the representation of equality. Here in computer science, the equal signs is called gets. So x gets 5. So gets basically corresponds to the value to the right hand side is a value. The left hand side is a variable. So basically, this will read as follows. X will get the value 5. This doesn't mean that x is equal to 5. X gets the value 5. Now, Java will complain if I do this. Java will tell you, hey, you know what? I don't know what x means. It's undefined, the name x. And that is the reason why, because we never told Java to hold that for us. So 5 is a number, it's a whole number. So you need to tell Java, hey, can you please hold an integer called x, which is gonna get the value 5. If you do this, that's a different story. Java already stores in memory the value 5 that is being associated with the value x. So if you say later on, hey Java, what is x? Java will tell you 5. In similar fashion, we can do the same with y. Hey, please store an integer called y, which will contains the value 2. So you can ask Java later on, what is y? 2. What is x? 5. What is x plus y? And Java will recognize each correspondence value and will perform the addition. In similar fashion, you can do something similar like, can you please hold a value z, which will get the value of the addition of x and y. So what is z? 7. So that is interesting because now we can play with variables and we can make operations based on the variables. Another interesting thing that you can do here is because you can say z, which is now 7, c is going to get the value of z plus x. So let's pay attention on the following statement. The value z is going to get an answer after we execute the following. What is z at this point? At this point, z is 7 and x is 5. So you're going to add 7 plus 5, and that will give you the value of 12. That is the answer. Now, when you execute this addition, which is 12, you're going to assign it to the variable z. So now, if I do this, if I tell you what is z, z is now 12. What is x? Well, x still 5. So there's nothing there. But now we aggregate the value to the z. This is called variables. Remember the definition of variables, which is a placeholder, which is value eventually change. Well, this is the eventually. Now it's been changing. So now z change for the old value of z plus the value of x. Now that we have this notion of variables, what we can do, we can perform other operations, but with different data types. For example, we can do something called char c equals to a. So we can say to Java, what is c? The character a. Now we can create another character, well, for example, b containing this character a. What is b? Capital A. Now, this is what many of my students get confused because a lowercase and a uppercase, they're different letters. Yeah, remember that table that we discussed previously? That table basically associates a numeric value to each corresponding character, a decimal value. Now, how can we know that decimal value? You can do something called typecast. in order to extract the numeric value of each corresponding character. For example, C is that little character A. But if you want to say, I want to know the numeric value, you need to put the parentheses in front of the variable, and then you're forcing to extract the numeric value. In this case, will be the integer C. If I do this, check out what's happening. It gives you 97. If you remember that table, I'm not so sure if you remember this particular character, but that corresponds to a 97 decimal value for the character lowercase a. Let's do the same thing, but now instead of C, we got B. Now, B is uppercase A. What do you think is going to happen? It's going to be a numeric value smaller or greater than 97? Java has a priority based on the what we call lexicographically order. So lexicographically order gives you a priority based on the assignated numbers for each character that we have. So here, capital letters, what do you think is going to be? Is goes before or after lowercase? That usually is before. So that number should be smaller. Now, can we do what is C plus B? Can we make this addition? Interestingly, it's going to give us this value, right? 162. Why? Because at this point, Java recognizes that every character has a numeric value. So Java will basically add its decimal values together. Another thing that we can do is to make more fancier operations other than addition, subtraction, multiplication, and division. So we have what we call the math library. And the math library allows you to perform operations, for example, the square root, the power, sine, cosine, tangent, I don't know, different things that you can use in math on regular basis. So one of the popular ones is probably the square root. So we can do math.sqrt, and inside of the sqrt, you can put here the number that you want to perform the square root. Now, notice that math is capital M, right? It's because it's a library, and to be honest, it's an object. And then the dot basically says the following: from the math library, extract the square root from, and then you can provide the number here. For example, if I put here 16, the answer will be 4.0. If I put here 4, I put 2. If I put here 9, I got 3. 25, 5, and so on. Okay. Another operation is math.pow. That's the power. For example, if I say, what is 2 to the power 2? 2 times 2 is 4. What is 2 to the power 3? 8. 2 to the power 4, 16, and so on. There's more of these items that you're welcome to go in and take a look at this website. So these are some of the operations that you can perform in using the math library. The next topic that we're going to discuss is about the string. The string is, as I mentioned previously, is an object, right? But it's a sequence of characters in order to basically store them together. We discussed char, which is a character with the single quotes, but here a string has double quotes. The double quotes allows us to basically specify that we are working with strings, and we have the ability to work what we call with methods or some functionalities, as I mentioned it previously. What you see here is the Java API from the Oracle library. It describes basically all the different implementation of string, which means that you will see what we call the constructors. We can talk about the methods and whatnot. We're going to elaborate this more in detail, but here you can see the website where you can find this online. So string is not a primitive type, but It's used to store statements, like long statements, maybe just a very single character, but maybe multiple characters. So it starts with the double quotes, yeah, and that will basically identify that we're working with strings. Has special functionalities, they're called methods, and you have seen probably some of them in your books. Some of them are length, charAt, toUpperCase, toLowerCase, Substring. There's a couple of them. And then we use the concatenation. The concatenation is the process of basically joining or gluing different strings with strings or with different data types like ints. So basically that is the process. Concatenation help us to unify or to put together, glue, I don't know what word you want to use better, to put together different variables or different values together. That's pretty much what it says. There's more methods in the following document that you can see here in Java string. Let's go ahead and make the demonstration on string, shall we? So here we are again in the Java interactions, Dr. Java interactions. So what we're gonna do, we're gonna create a couple of strings and we're gonna play with them. For example, we have string, let me just call it X, will contain something like this. So here, if I ask Java, what is X? And Java will tell me, hello guys, how are you? Yeah, that's notice that there is a reddish number there, color there. And you can see a couple of things here. If I ask you how many characters you have in that string, I don't doubt you have an incredible counting skills, but it's too much. I mean, I don't have the time to go and count. And instead, I'm gonna say the following: X, which is a string, contains a, extract the length. Give me the length, open close parentheses. This is a method that will permit to extract from Java, the string, a total size or length from that particular string. So there's 25 there. If you don't believe me, you can just go and count them on your own. So that's one of the methods. Now, we can also have in X, give me the character that is positioning at this position. So what is the position you want? Suppose that you want the first character from that string X. You might think it's H. So if you put the number 1, you're probably expecting H, but instead we got something E, which is not cool. So what happened here? So Java, as many other languages, is what we call zero-based indexing. So every value that we can start counting, we start at position 0. Not only in strings, but also we have something called arrays, and we have list and whatnot. Okay, so a zero index-based language basically tells you that you start counting at 0 and not 1. So if you want to extract the very first character, the only thing you have to do here is extract position 0. If you want the second one, third, fourth, fifth. So remember that I told you that we have 25 elements. Here, we count 25. Now, you notice that we have until 24. That's our very last character. If I put 25, notice what's going to happen. Java will basically throws you what we call an exception. In particular, we're going to have string index out of bounds exception because you're going far away from the index that you can have, 25. Yes, I know, we do have 25 characters, but we remember that we start counting at 0. So we can have only access from 0 to 24. 25 is out of the index, and that's why it says there, this particular exception. We're going to talk about different items in this course. One of them is errors, that we probably have the syntax errors, we have the logical errors, we call the semantic errors, but we also have exceptions, which is the runtime exceptions like this one, because we don't have access to that particular bound. So that's why you're gonna deal with a lot of those errors and syntax errors during this course, during your entire life, as a matter of fact. That's how we get this process that we call debugging. So when you debug a problem or a program, basically it tells you how to go in step by step and identify what was wrong. Probably was a syntax error. We were able to fix it, or basically the compilers let you know that there's a problem with that. Runtime errors or exceptions are more difficult to trace because the user gives you interaction like what we're doing right now, and then you will have to trace it step by step. Logical errors probably are more difficult to debug because that means that your algorithm, your way of thinking is not clear, is not coded correctly. So that's some of the stuff that you're gonna find out later on. So I did this on purpose only to demonstrate this particular error or mistake, right? Depends how you want to see it. I recommend to watch a couple of other tutorials about how to learn through these mistakes, and we discuss this more further. Okay, so what else we can do here? So if you remember what X was this. Hello guys, how are you? So notice that we have a combination of lowercase and uppercase. You can also do something like this, X dot to uppercase. So to uppercase basically tells you all in caps, right? Now, notice that here it's all caps, and that's okay if you want to do something like that. If you want to yell at someone through text messages or screaming in conventions, I don't know, you can do that thing. But notice if I say, what is X again? Java will tell you the original one. So you never change it. And the reason is because you in X, you basically have only accessing the method in local places. So if you really want to change the value of X because it's a variable, you need to say X will get the value of X dot to uppercase. So now if you tell, hey, what is X? Hello guys, how are you? Yelling, right? So you can do that thing. Now, if you want to change it, then if there's an uppercase, there's gotta be something called toLowerCase. You see how everything got translated back? But if I say X, X will still yelling at us with all that. So you can do what you can do. We can simply do the similar things. X is gonna get the old value of X toLowerCase. So now we can say, what is X? That. So this demonstrates a couple of the functionalities of string. There's one in particular that I like a lot. It's called the substring. X.substring will basically specify a position. For example, if it's 4, it will give you, oh guys, how are you? Why is that happening? That particular index that we're providing here is going to tell, go to position 4. This is 0, this is 1, this is 2, this is 3. O is at position 4. So basically you're telling, go to position 4 and give me the rest. Oh guys, how are you? Now, suppose that I only want to get the how. So remember that the how goes in which position? Position 12, right? So we can do similar thing. So we can do position 12. We can get, how are you? This is only a substring that we got. So if we want only the how, we can also say, give me go from 12 to 14. That will give you, I know W is in 14, but is not inclusive. So I want you to pay attention on that. The number that you put in the second place is not inclusive. And if you want to include the W, then you have to go one more, in this case, 15. So Substring helps you to basically chunk or trim certain pieces. If you know those indices, then it will help you out tremendously. So we discussed basically how to manipulate the interactions in Dr. Java from whole numbers, doubles, characters, and what we consider to be an object string. So here we have, or we learned that the string contains a variety of methods, similar as math, the math library that we use for the square root and the power. There's a couple of methods there of functionality that can help you and assist you to do more interesting things. You can go and take a look at those two libraries that you can find there, and it has more methods. Of course, I want you to go in and read a couple of them because it will help you in order to recognize more items or more operations that you want to do. Notice that the string has this big list of different methodologies or functionalities that you can do. Is because string is widely used in computer programming. So take a look at those. Check on the APIs that we provide here. And in case you have any questions, please let me know, and I'll be happy to post it. See you next time.